Hi, in this video we are going to learn how to route inflow hydrograph through a reservoir using the level pool method or modified Puls method. Um, as usual, we are given the inflow hydrograph, so these are our I values. We are given initial condition, which is the storage, so we are given initial storage, and we know that these are the two equations we have for modified Puls method, which is 2s over delta t, 2sj over qj is equal to ij plus ij minus 1 plus 2sj minus 1 over delta t plus qj minus 1. Okay. Now, as I discussed in the modified Puls method, we have two unknowns here. And to resolve that issue, we develop what we call storage outflow function. And the storage outflow function is basically relationship between 2s over delta t plus q versus q. Okay. And we are going to develop this relationship by using the storage discharge relationship that is given to us. Okay, now the storage discharge relationship can be given as an equation or a function, or it can be given in the form of data, which is what you see here. So what we have here are S values and Q values. By using this, we will develop the storage outflow function, and what is given here is an empty table to populate the storage outflow function. So the Q values that you see here are the same Q values that is given to us. Now we are going to calculate 2s over delta t plus q by using the storage discharge relationship. So I'm going to just do this for one or two values, and then you will know how to do this, and then we will see how to do this in Excel also. So the initial Q is 0. So for that I'm going to say 2s over delta t plus q is equal to, so when q is equal to 0, s is 3.35 to the power of 6. So 2 times 3.35 10 to the power of 6. So that's our 2 times s, and delta t in this case is 6 hours, and our Q is in meter cube per second. So I'm going to convert this 6 hours into seconds. So 1 hour has 60 minutes and then 60 seconds. Okay, and then our Q is 0. And when you solve this, what you get is 310.185, or you can say 19 meter cube per second. So this value 310 plus 19 will go here. Okay, I'll zoom in. So this is 310 plus 19. It looks like 316, but you know it's 310. Now let's do this one more time, and then you know what to do here. So our next Q is 10. So when Q is equal to 10, 2s over delta t plus q is equal to, so when q is equal to 10, our s is 3.472. okay, so I will use that 3.472, and we have 2s, so I'm going to multiply this by 2, 10 to the power of 6 divided by, again, 6 hours times 60 minutes times 60 seconds, and our Q is 10. So again, you solve that, and then you should get 331.48 meter cube per second. And you can do the same, so I'll write one more value when q is equal to 26. So this is meter cube per second, meter cube per second, meter cube per second. Our 2s over delta t plus q is 385.26. So we had 310.19, we have 331.48, and then we have 385.26. And similarly you can populate these other empty cells here. Okay, so when you do this, what you have is our storage outflow function. Now you may say these are just values, it's not a function. So what you can do is you can plot that in Excel, and these are the points that we plotted by using the values we have in this table. So these values are plotted in this plot. Okay, and we have created a relationship. So basically y equals to, so in this case y is our q, and the relationship we have is 0.3566, and x is our 2s over delta t plus q minus 111.35. So this is our storage outflow function. Okay, so we have storage outflow function now. Now we are going to use the equation we have for modified pulse, which is 2sj over delta t plus qj is equal to ij plus ij minus 1 plus 2sj minus 1 over delta t plus qj minus 1. So let's see how we can now get the outflow hydrograph by using our storage outflow function and this equation. So what I have done here is I have set up this equation in the form of table. So our initial discharge is given to us. Well, initial storage is given to us, which is 3.472, and corresponding to that 3.472 we have a discharge of 10. Okay, so let's do that. So what we have here is 10, and we calculated this value also 2s over delta t plus q for that 10, which is 331.48. So we can populate that also. So 331.48. Now this column E, which is this part, has 2s over delta t minus q. Here we have 2s over delta t plus q in column F, but in column E we have 2s over delta t minus q. So what we can do is, so basically our F column is 2s over delta t plus q. Now if I subtract 2q from this, which is our column G, you get 2s over delta t minus q. So basically column E is F minus 2G. Okay, once we do that we get that. So in this case 331.48 minus 2 times 10. So 2 times 10 is 20. So this is 311.48. Okay, so this is basically our initial condition, which is what we have. Now let's find out the Q or the outflow value when we have time equal to 6 hours. Okay, so ij plus ij minus 1, so we are going to add these two values. So 10 plus 20 is equal to 30, plus 20 is equal to 30. Okay, so that's what we got. Now that is ij plus ij minus 1. Now 2sj minus 1 over delta t plus qj minus 1. So this is basically 2s over delta t plus q from previous time step. So what I'm going to do is I'm going to add 30 plus 2s over delta t minus q from the previous time step, and then I will get this value, which is the right hand side for the current time step. So 311 plus 48 plus 30 will give me 341.48. And once we have 341.48, we are going to use that value here. So I will just write down. So to get this value, I'm going to say 0.3566. So Q is equal to 0.3566 times our, so basically I'm using this equation at this point. So 2s over delta t plus q. So for that we have 341.48, okay, minus we have 111.35, 111.35, and once you do that you will get 10.42. So this will be 10.42 meter cube per second. So this value will go here. So 10.42. Oops, 10.42. Okay, now we are on to the next row. So for next we have 20 plus 55. So 20 plus 55 is 75. Now to get column F, we need this value here, which is empty. So for that again we will use F minus 2g. 341.48 minus 2 times 10.42. So that will give me 320.64. Now I'm using two decimals here, so depending on the number of decimals you have, you may get slightly different values, but that's okay. So once we get 320.64, I will add 75. So 75 is our ij plus ij minus 1. 320 is our sj minus 1, or 2sj minus 1 over delta t minus qj minus 1. So we will add these two values to get this value here. So 320 plus 64 plus 75. So this will be 395.64. Once I have 395.64, so again I solve for Q, 0.3566, 395.64 minus 111.35, and that will give me 29.73, and this value will go here, and then we just keep continue until we reach the last row. So this is how you can do it manually. Now let me show you how we can do this in Excel. Okay, so this is what we have in Excel, and I have already calculated the values that we need for the storage outflow function. This is the equation we saw, y equals to 0.3566x minus 111.35, and then this is the table that I set up in that worksheet. So here ij plus ij minus 1 is this plus this, so that's 30. And then we had our initial condition, so this is 10, and then 2s over delta t plus qj was 331.48, and then this was column f minus 2g, so this minus 2 times this. Okay, and then we add 30 plus 311.48 to get this, so that will be this plus this. And once we have this, we will now use the storage outflow relationship, which is this equation y equals to 0.3566 and so on. So that will be 0.3566 times our 2s over delta t plus q minus 111.35. Okay, so this is what we had, 10.42. Once we have this, so again we can subtract 341.48 minus 2 times 10.42 will give me 320.64, which we had. So this will be, now all we have to do is copy this, similarly copy this, similarly copy this. You will see negative values sometimes until you populate everything, and we can go one more actually. And as I said, you saw negative here, so let's bring everything down. And that is our outflow hydrograph. Okay, now let me plot this also so we can see where the peak falls. So insert, want the line, so select data, so we will add inflow first. So that's our series name is inflow, and values are this, and then let's add outflow. So series name is outflow, and then values are this. Okay, and I don't know why this, maybe this is an error. Let me see if I made a mistake there. So 36 after 36. Yeah, so let's fix this. So instead of 55, let's, just to show that, so after 36 maybe let's make it 25. Okay, and remember we discussed about where the peak will fall. So with linear reservoir and also with modified pulse method, the peak of the outflow will fall on the falling limb of the inflow hydrograph. Okay, and I can zoom in to show you that. Okay, so you can see the peak is here and it's falling on the falling limb of the inflow hydrograph. Okay, so this is all for this video. I will see you next time. Thank you.